let's discuss a new problem, which is GCD of two numbers. So in mathematics, in like 7th or 8th standard, we had already learned that what is GCD, that is greatest common divisor, or other name is HCF, highest common factor. So what is divisor and what is a factor? So divisor means in specific GCD, the greatest common divisor means the number of that particular number which can easily divide the number and leaves a remainder 0. If we do factorization of 12, for example, here I am taking simple example, very small example of two numbers. I am not taking here three numbers. The three numbers follow a different methodology. For two numbers, we just do factorization, and after that we just find out the which is the common least number which can be found out in both the numbers. In this case, if we factorize 12, then we could get 2 into 3 into 2, and if we factorize 6, then we get 2 into 3. So which is a common number and also it is a smallest number. So 2 into 3 is the smallest. So answer is 2 into 3, that is 6 is my GCD of this two number. So today we learn about how to find out by using computer the GCD of two numbers. For GCD of three numbers, there is another methodology. We have to divide, that we will discuss in if possible in another video. Let's discuss the two solution of GCD, which or HCF. The first is knife solution. So in simple way, what we did in dry run, that is we just find out the divisors and we divide by smallest number, that is 6, and if we find out that remainder remains 0, then we say that it is okay, then it is divisor. That's it. So for this also we have to find out the minimum number between 12 and 6. We have to use a while or for loop, and we have to go iteratively and find out each and every number is divisible by that minimum number. If both the numbers are divisible by that minimum number, then that's it. We are GCD is in our hand. So that is GCD. And if it is not, we go again further. So let's try to code it. So int GCD, here we take two number, int a, int b. The first thing we should do, we store minimum number between a and b. Why minimum, not maximum? Because GCD definition itself tells that the greatest common divisor. So divisor means the number which can divide both the numbers and which should have a minimum value. So that is the definition. So we find out first minimum, then we run a while loop, that result is greater than 0, and for we decrement the for loop because we have to end this, otherwise it will go into infinite loop. So then we put a condition that a mod result is equal to 0 and b mod result equal to 0. That means our minimum number, which is the result, successfully divide both the numbers at a time. That means it is a divisor. Itself it is a divisor, but we are not for sure that it is a list. So to check that it is, if it is a list or not, we have to decrement result at each time by 1. And when we got that, what we should do, we break from the loop and we again decrement result. For example, here 12 and 6, let's take the same example. Here 12 and 6, if 12 divided by minimum of 12 and 6, that is 6, so it gives remainder 0. Again 12 divided by 12, it gives remainder 0. So we break the if. So we just go outside that and we decrement result by 1. So it is 11. We check that if it is so it is not given. So 10, check again. 9, check again. 8, check again. 7, check again. Not 6. So when we result is 6, then 6 divided 12 divided by result or 6 divided by result, it gives us a remainder 0. So we break from the loop. Then we result decrement. But after decrement, we are not getting a number which can successively divide those numbers and let be the remainder 0. So our answer is, that's it, 6 only. So return result. So this is a nice solution. Let's check the code. Then we will discuss some better solution, or which is a Euclidean solution. Euclidean solution is basically a recursive method to solve the GCD of two numbers. So let's see what we are getting. Yes, so we are getting here 6 as a number. So our GCD is 6. We run code successfully. Nice solution is running very well. So just comment it out. And try to write the Euclidean solution. So before writing the code, I have to tell you one thing, that in GCD, if you take a pen and paper and if you find out that there are two numbers, I'm not considering the case of three numbers, I'm considering the case of two numbers. If my B is 0, automatically my GCD is A, because 0 factorization we can't possible. It is not doable. So itself GCD is A. So we don't have to need anything, we just return A only. But when A and B are non-zeros and they are large or medium or any size, so what we do, we just take mod of that number, that is A mod B, and we again return to GCD function, a recursive function, tail recursive function, and we take B as A and A mod B as a B. So why we do that? So if you take here example, just take a simple example, because if we take simple example then it is easier to understand. So 12 and 6, if I take a as a 6, consider here my A as a 6 and my B as a 12 mod 6, which I get 0. So in one go only I'm getting B as 0, that means my GCD is 6. Let's take some different example and let's dry run the code so that we can understand very easily. So let's take 36 and let's take B as a 12. B as a 12. So when we call GCD function, a Euclidean method, so GCD of B, A my B, and here 36 mod 12, which I am getting 0 again. So what is my GCD of this two number is 12. So let's take some different example, then we can, let's take 48. So if A is 48 and B is 36 mod 48, then we are not getting remainder as 0, we are getting remainder as a 36, because it is smaller than that number. So remainder is 36. So again we call GCD function recursively. So A is my 36 and my B is 48 mod 36. So let's calculate the 36, 48 mod 36. So 36 1s are 36, 36 2s are 72. So it 2 it is not required. So 1. So 1 only. Then what we get? 2 minus 6, that is 2. Sorry, 8 minus 6, that is 2. 4 minus 3, that is 12. 4 minus 3 means 12 is answer. So again we call GCD function. A is my 12 and B is my 36 mod 12 mod 12. Then I'm getting the remainder as 0. That means 12 is my GCD. So let's code it first. So as you go through the dry run, you already know that what I'm telling to you, that is, if B equal to 0, then return A, else call GCD of B comma A mod B. So that's it. This is a Euclidean solution. So let's take the same example, that is 36 comma 48, and let's see what we are getting by this solution or this efficient solution. If we are getting 12, then we can sure that we are successfully running the code, and also our dry run is pretty sure. So 12 is the answer. That means we are doing great things. So that's it. This is GCD function, very simple to code. Stay tuned, like, share, subscribe if you like my effort. Stay blessed. Thank you.